Hi, Algebra 1. In this lesson, lesson 5, you're going to be looking at quadratics and figuring out how many solutions are there. Are there 0, 1, or 2 solutions? Here we go. This first one is false because negative 3, if I plug that in for x, it would also make it equal to 0. Negative 3 squared is negative 3 times negative 3, which is positive 9, and so that is 0 as well. So there's 2 solutions to that first one. The second one is false because if I plug in negative 5 for x, negative 5 squared, that would be negative 5 times negative 5, which is a positive 25. That is not going to equal 0. This third one is true because x could equal 0 or x could equal positive 7, and it would make that equal to 0. This last one is false because if I plug in 5 for x, here, and you simplify and multiply it out, you would not get the whole thing to equal 12. It would equal 0. And if you plug in 7 for x here and here and simplify and multiply everything out, it would equal 28, which is not 12. When Han graphed this, he would see something like this. And first of all, let's look at the solutions. We see that it's crossing the x-intercept at x equals 3 and x equals 5. And why does this work? Well, when you're looking for x-intercepts on the graph, I can see the coordinates of this point are 3, 0. The coordinates of this point are 5, 0. And that means that when x is 3, the whole thing is equal to 0, or the y value is 0. And everything on that x-axis has a y value of 0. So whatever those x-intercepts are, for example, this one's 5, that's saying that when x is 5, the whole thing is equal to 0. So before we do anything here, let's make sense of what the second question is saying. It says to solve the second equation, Han rewrote it like this. You can see that plus 1 is right there. So looking at the equation, this is what he did. He added 1 to both sides of the equation. And what he ends up with is x minus 5 times x minus 3 plus 1 equals 0. Notice that that plus 1 is just hanging out here on the end. It's not being combined with anything here, because these things are being multiplied together. But now the whole thing equals 0. The instructions say to graph this using a graphing calculator. I highly encourage you to do this on your own so that you can make sure you can find these solutions. You can see that the graph is touching the x-axis right here at 4. And so our solution is x equals 4, because that's when the whole thing equals 0. Remember, Han rewrote it so that the whole equation would equal 0. Here I've taken the way that Han rewrote the equation to equal 0, and I've plugged in 4 for x. That's what we see as our solution from the graph. And we're just going to simplify and just make sure that this does end up equaling 0. And so we end up with negative 1 plus 1 equals 0, and yes, it is a solution. It does make the equation true, even after Han rearranged it. Now we're going to solve the third equation using Han's strategy. So first thing we need to do is get it equal to 0 like Han did. So I'm going to add 4 to both sides of the equation, and we end up with everything that's being multiplied is still going to be there. We just have the plus 4 now over on its own. And now we're going to graph this. We're going to graph the equation when we type it in, x minus 5 times x minus 3 plus 4. So graph that and find the solution. So remember, we're trying to figure out when does our equation equal 0 because we rearranged it. And I can see from the graph that it's never touching the x-axis. There is no value for x that is making this equal 0. So my answer here is that there's going to be no solution. There are no values for x that make the whole thing equal to 0. So why is it helpful to rearrange the equation to equal 0 and then just graph that? Because it makes it easy to see how many solutions there are. You're just looking for x-intercepts then. And I'm just going to write that down here. When you do that, you're looking for x-intercepts, which are easier to see and find on the graph. How many solutions does each of the 3 equations have? Well, we just found out that number 3 had no solution. Number 2, we saw 1 solution. That was when it just touched the x-axis when x equaled 4. And then number 1, we see 2 solutions because it was crossed the x-axis twice. We're going to work on solving these equations. These first three you can solve by reasoning through, or if you'd like to graph them to help you, you certainly can. You're looking for what values of x make the equation true. There might be one answer or there might be two answers. In the first equation, we're looking at what number times itself, that's being squared, is going to equal 121. I know that 11 squared is 121, and this might be a little bit of trial and error. Use a calculator, try things out, but always be careful to see if there's another answer. And in this case, there is. Negative 11 squared would also be a positive 121 because that's negative 11 times negative 11, which would be a positive. Here we have x squared minus 31 equals 5. I'm going to get that x squared by itself by adding 31 to both sides. So I have x squared equals 36. So now I'm thinking, what number times itself gets me 36? Well, x could be 6 because 6 times 6 is 36. Or x could be negative 6 because negative 6 times negative 6 is going to be positive 36. In number 3, this looks really similar to other stuff we've been doing. I can see that if x equals 4, and that actually goes for both of these terms, then the whole thing is going to equal 0. These equations, numbers 4, 5, and 6, you may want to try graphing, similar to how we did in the previous activity to solve these. And one little hint is that they're not currently equal to 0, but you can rearrange them to make them equal to 0. To make this equal to 0, I subtracted 5 from both sides of the equal sign, so I end up with x plus 3 times x minus 1 minus 5 equals 0. So then when I graph that equation, I'm looking for when it equals 0, which is my x-intercepts. And so I end up with the two answers, x equals negative 4 and x equals 2 as my answers. In number 5, to get it equal to 0, I added 4 to both sides, so I have x plus 1 squared plus 4 equals 0. On this graph, we can see that it does not touch the x-axis, and because of that, there are no solutions. Because the x-axis is where everything would equal 0, so there are no values on my graph where the y value is going to be 0. I just want to show you using number 6 a different way to solve this. Notice that over here I have graphed the x minus 4 times x minus 1 part, and then I've graphed y equals 990. And you're looking at where that point happens on your graph, and you can see that when x is 34, the whole equation will equal 990. So when x is 34, the whole thing equals 990. Or we could go over this way, and we'll see another point that when x is negative 29, the whole thing equals 990. If you do it how we've been doing it so far, getting it equal to 0, you would subtract 990 from both sides. You get this equation. And when you graph that equation, you'll see that it crosses the x-axis at negative 29 and 34. Those same answers that we just saw, but it is a little bit easier to find them when they are just crossing the x-axis. Now make sure that you are graphing these as you go through this video, because this graph especially will not look like this when you first graph it. You have to practice how do you get the scales to be correct so that you can see the graph for the parabola that it is and not just like straight lines up and down.